Hello everyone, welcome to this channel. This question is from Olympiad Pathfinder Chapter 12, Build Your Understanding, question number 3. The question says the two beads of equal mass m and unlike charges of modulus q1 and q2 can slide on a fixed frictionless non-conducting rod. So these rods are frictionless and these two charges are having the unlike charges, means one is positive then the other will be negative. And these rods are bent at right angles. Initially, the beads are held at rest at distance d and 2d distance away from the corner. Okay, so at this location, it was at rest and particle 1 was also in rest. And then released simultaneously. When one of the beads reaches the corner, what will be the position of the other beads? Let us solve this question. Since the charges are unlike, so it will attract each other. So let us say that force to be F subscript E as shown in this diagram. At this location, velocity of particle 1 was 0. Here also particle velocity was 0 because in the question given, these two charged particles released from the rest simultaneously. So what will happen when we release this particle 2 and particle 1 from the rest? The force is acting in this direction on particle 2. So it will have a component in the y direction. We have taken y direction as downward and x direction as this. So it will have a component of force in the y direction, due to which this particle will be having an acceleration in the y direction, and that we have notated by is subscript y. And what will be that acceleration? The component of force in the y direction, that is F subscript E sine theta divided by its mass. Putting the value of sine theta from this triangle, theta we have taken this angle, so perpendicular by hypotenuse, perpendicular is d, square root of 5 into d is the hypotenuse, and we say it as equation 1. Similarly, we will calculate the acceleration of particle 1 in the x direction due to the component of force F subscript E in the direction of x. So component of force in the direction of x is Fe cos theta, and we will divide that by mass of the particle. So we will be getting the acceleration in the x direction. Upon putting the value and comparing with equation 1, we will come to know that acceleration of particle 1 in the x direction is 2 times the acceleration of particle 2 in the y direction. Now let us consider an infinitesimally small time dt. This dt is so small that we can say it is tending to 0, almost 0. For this infinitesimally small time dt, the acceleration of both the particles can be considered as constant. The particles have started from the rest. Therefore, the distance covered by each particle can be written as, for this particle, half into ay into dt square, and we say it as ds. And also we call it as d2. 2 stands for particle 2. So we get number 3 equation. Same way for this particle 1, we can write half into ax into dt square. But we know that ax is 2 times ay. So we will put that value. And we will get 2 times ds. And that we can write further as d subscript 1. 1 stands for number 1 particle. And we will say this equation number 4. So since this distance is 2 ds and this distance is ds, so remaining distance will be 2 into d minus s here, and in this will be d minus s. So if we divide perpendicular to the base, we will be getting a ratio of 1 by 2. Initially in this triangle also, if you see, this distance was d and perpendicular was d and base was 2d. The ratio was 1 by 2. So it means this triangle and this triangle is similar triangle. So what will happen then? This angle will be equal to this angle. So this angle has been shown as theta correctly. Now if we calculate for velocity of particle 2 after dt interval, so it will be ay into dt. Same way for particle 1, ax into dt, but ax is 2ay dt. So the particle 1 velocity is double the particle 2 velocity. Now at the new location, after traversing a distance ds for particle 2 and 2 into ds for particle 1, let Fe dash be the force after dt interval of time. The force has changed to Fe dash, Fe primes. So after dt interval of time, the acceleration of particle 2 can be written as a prime subscript y Fe prime divided by m into sine theta, and we'll put the value and we'll get this equation 5. Similarly, for particle 1, the component of force in the x direction, Fe prime cos theta divided by m, and we'll be getting 2 into a subscript y prime. Means acceleration still is double the acceleration of particle 2. And if we consider another dt interval of time, the particle 2 will cover a distance d2 dash, and we'll say that as d2 dash. And that can be written as initial velocity into time, that is ay dt. After dt interval, if first dt interval, the velocity has become ay dt. So that ay dt into dt plus half into ay prime into dt square. Same way for particle 1, in another dt interval of time, it will cover a distance d1 prime, and we can write to initial velocity for that new location was 2 ay dt for particle 1. So 2 ay dt into d plus half into ax prime dt square. And upon solving, we will be getting that this distance is d1 dash is d1 prime is equal to 2 into d subscript 2 prime. Therefore, it can be concluded that for each such interval of dt, distance traveled by particle 1 will be twice the distance covered by the particle 2. So initial gap from the corner O was 2d and d respectively for particle 1 and particle 2. Therefore, when the particle 2 covers a distance of d to reach the corner O, the particle 1 will also be at the corner O by covering a distance of 2d. So it means both the beads will reach the corner O at the same instant of time. Please go through my writer. It will give you ease in understanding. In case anywhere you feel doubt, please write in the comment box. I will come back on it. Thank you.